So what I would do today is just talk briefly about the COVID-19 lockdown and urban air quality. So this is a very recent publication, exactly 7 o'clock on 13th of January, so, last Wednesday that was published. So why we are interested in air quality? Globally, we're talking about 8.8 million people die prematurely every year. And in the UK, that number is relatively low, but is still astonishingly worrying. I'm talking about 30,000 people die every year prematurely due to air pollution. And the estimated cost to our economy because of air pollution is about £20 billion. And there's last December, there's an inquiry which find that the death of the 9-year-old Ella is partly because of the air pollution. So there is a very compelling evidence that air pollution is a big problem for us. So the lockdown gives us the excellent opportunity to understand the changes in economy and mobility and its effect on urban air quality. So before the lockdown, you would normally see a lot of traffic jams. After the lockdown or during the lockdown, we see much less. And this is the data from transport. Department of Transport. We can see a very much decrease in the traffic after during the lockdown, and a major increase in the bicycle. That's the on the top. It's the bicycle. Of course, eventually it goes somewhat back to normal from in the summer. So earlier report in April and later in October, not only in the UK, but globally, you see lots and lots of media coverage about the huge improvement of air quality because of the lockdown. And this is the report from The Guardian. Now, there are a number of things we need to look at when we are looking at the air quality improvement. So the normal things that we do is we can look at the concentration of an air pollutant, for example, nitrogen dioxide, during the lockdown, comparing those to previous years. The challenge of this is, one, we don't know whether the meteorology is going to be the same during the different years, and if they are not the same, the concentration levels would not be the same. And the other thing is, if you see the figure down here, you can see the concentration of the air pollutant, such as nitrogen dioxide. It goes down year by year. So whether we have a lockdown or not, we will see the concentration in 2020 normally, and the normal meteorological conditions to be lower than the previous years anyway. So if we look at the big differences between these two lines, we actually are attributing part of this to because of the lateral processes, like changes in the vehicle fleet, improvement in the in a vehicle emissions. So something's happening naturally whether we have a lockdown or not. So if we look at the concentration before and after, we're having a problem. So the effect is much lower. And the other bigger effect is air quality. It's meteorology. Now, I don't know how whether our audience have this knowledge or not, but looking at this example here to the right, you can see the daily variation of concentrations of nitrogen dioxide in Paris. So you will see a lot of changes whether or not you have lockdown or whether there's a intervention. So you can see here that this line, vertical line, is the lockdown date. And so if you look at the peak concentration before the lockdown and the lowest concentration just after lockdown, you're seeing 90% of the changes of decreasing in nitrogen dioxide concentration. That is not because of the lockdown. It's partly because of lockdown, but partly because of the meteorological changes. So just give you an example, when we have really good meteorological conditions, you've got strong wind, most of the pollution essentially has been blown away. But under very stagnant air conditions, the pollution is going to keep building up and your concentration becomes higher and higher. And in this case, for example, this is mainly because of the better meteorological conditions. For example, wind blow away the pollution. So that is what we studied. So the question is, people have seen that in April, see lots of blue skies, and we just feel that air quality is much better. And that is because of the lockdown, but actually that is not necessarily the case. Now, one example we look at here. So this is the air quality, the wind direction and wind speed in January to March, and this is before and this is after the lockdown. You can see a huge difference in the meteorological conditions before and after. That have a major impact on the air quality. So what we did is we using a machine learning technique, we de-weather it. Essentially, we try to remove the weather effect. This is what we did. So we have the daily variations of concentrations. If we removed meteorological effect, that would be what we call de-weathered concentration. And you can see this kind of a saw shape. That is simply because the weekend effect. So we capture the weekend effect very well. During the weekend, you have a lower emissions, fewer people using cars, so your concentration is going down. But what interesting you can see here is during the lockdown, just before the lockdown, you can see a very sudden decrease of the air pollutant concentration. That is what we believe this is a real. Yes, with the lockdown, we got a big abrupt change in concentration. This is nitrogen dioxide, but in the meantime, we have a problem with the ozone. Ozone is the lesser air pollutant, and during the lockdown, you can see the ozone concentration goes up in almost all the cities. So on the one hand, we've got the effect, we have the abrupt changes, improvement in nitrogen dioxide, but the effect is not as big as we would see from the observational data. But on the other hand, we have this ozone increment in the cities. So what we also did is there's another effect which we have to look into. So during the let's say from the winter to the summer, so we use less heating, for example, where the emissions will change whether we have lockdown or not. So this is the trend on the top is lateral changes. Whether you have a lockdown, this is what will happen. This is going to usually you will see the changes in the concentration of the pollutant. So what happened in 2020 is we have such a much bigger change. And if we consider that lateral trend, because of the emission changes from the winter to the summer, we will be able to look at the real changes. And that is the real change during the lockdown. So what our result actually shows, so let's see just very quickly, this is one more slide. If we look at the observed changes before and after the lockdown, let's say in Beijing, we got like a 40% decrease in the nitrogen dioxide concentration, but what you can attribute to the lockdown is only 18%. In Wuhan, for example, it got 47%, but actually you only have 34% because of the lockdown, and the rest is because the two things we talked about, weather or the lateral changes of pollution emissions from the winter to the summer. So that key message here is air quality improved, particularly nitrogen dioxide concentration decreased, but overall they are not as big as we thought. And ozone concentration actually increased. What does that tell us in terms of air pollution control? The air pollution control is more difficult than we thought, basically, and it needs a coordinated efforts towards all major air pollutants. And that's all from me. If anyone is interested in this more public-facing conversation article, this is the conversation article you can see from here. Thank you very much.
Thanks so much, Zongbo. It's really, really interesting.